Okay, so for this car, the friction is to the right and the normal force upwards, so the net force should be diagonal. So answer is B. Okay, those who got B, good, very good imagination. You can't think friction is to the left. The friction is to the right if you focus the wheel, because the wheel won't tend to move to this way, to the left way. So friction is going to push it to the right. So therefore, B is the answer. Any questions from here? Everyone can understand that. Okay, we move forward. Okay, another tricky one. November 3, question 11. Give me the answer. Anyone got the answer? A molecule of mass m traveling horizontally with velocity u hits the vertical wall at a right angle to the wall. It then rebounds horizontally with the same speed. What is this change in momentum? You see the wording here. First they say velocity, later they say same speed. Okay, speed, velocity different. So anyone? Okay, let me check. Is there any chat? Okay. So this is the new answer. B, is it? Or this is the old answer, is it? B. Okay, go back to the question. Yeah. So let me give a try. So I believe all of you got the answer already. Let me park this here. Maybe park this up. That's all. Okay. So the wall is here. Okay, you have a wall, and an object is moving to the right with the velocity of u. It's a velocity u, and has a mass of m. Then after collide, it bounces back. Okay, with same speed, not same velocity. Of course, cannot be same velocity because direction changing. If to the right is u, means to the left must be what u? Negative u. The velocity is negative u. So the momentum to the left is negative mu. Okay. So they want what is the changes in momentum? Changes in momentum is what's answer? The final momentum. Yeah, minus with the initial momentum. Okay. So final momentum is negative mu. Yep. Any question? You can see the question.
The question is the uniforms the resulting force acting on it. It's a different. I think it's a different question than Wise teacher explaining.
Okay. What you can seeing on the screen now? Question 11, right? As you do.
Oh, okay.
A molecule of mass m traveling.
Okay.
This is the question. This is what you are seeing, right? Okay then. So I'm explaining this question. Okay. Question 11. You tried already?
Yes.
Okay. So I'm explaining this question. Okay. So some of you put answer. This is D. Okay. D. Okay. Let's go for D. Negative 2 mu. Is it negative 2 mu? So final momentum is negative mu. Negative mu. So minus initial momentum is mu. That's good. So finally you got negative 2 mu. Yeah, correct. So the answer should be D. D is negative. The magnitude is 2 mu, but negative tells the direction. Okay, the direction is to the left. The changes of momentum happens to the left. Okay. Okay, three quantities always same. When the ball is collide with the ball experience force. Which direction the force experience force due to the wall? To the left or to the right? When the ball collide with the ball experience force. Which direction the force experienced by the ball? To the left or to the right?
Left.
Of course, to the left. the force is to the left. Therefore, the acceleration should be also to the left. And third member is what? Therefore, the changes in momentum also must be to the left. Okay, these three quantities always same direction. I already told you this earlier. Force, acceleration. So the negative tells what? The changes of momentum happen is to the left, because we take to the right as positive. Okay, so negative 2 mu. Good. Those who get negative 2 mu, good. Keep it up. So as we move on. Okay, I'm just taking the randomly. Okay, this one. Similar, November 4, question 11. You will try? Okay, 11. What is the answer? Okay, so can you put it on the chat again? So let me see any answers of all of you. B. Okay, let's see. Is it B? B. Yes, good. The answer should be B. 2 mb to the left. Okay. So when the ball collides to the wall definitely will experience force to the left. Therefore, changes in momentum also must be to the left. Acceleration also must be to the left. So changes in momentum must be 2 mb added. When ball go and collide and bounces back, that's the biggest, greatest changes in momentum ever can experience by the body. When bounces up backward. Okay. So let's say someone threw a tennis ball at the back of you. Okay. So if the tennis ball, tell me which one could be very painful for you. And the tennis ball collide and just stops, or a tennis ball collide and bounces back with the same velocity. Which will be more painful for you? The one bounces or the one stops immediately after collide? A tennis ball and throw towards you, collide at the back. The tennis ball hit and just stopped. Another one hit and bounces back. Which will be more painful for you?
Bounce.
The one bounces. Why it's more painful for you? Because greater changes in momentum. Big changes in momentum. The changes happen, big changes in momentum. In a shorter period of time, of course, time matter, you get a big force. Okay. So anything bounces back, the force you're going to exert is huge. So in this case, 2 mb, biggest changes in momentum. So answer is B. Those who get B, good. Let's move on. Okay. June 5, question 10. Give me the answer. Which is not one of Newton's law of motion out of these four? Okay, give a try. So let me check what answer.
So I can't see.
It's B.
Oh, I can't. It's okay. You can't see the answer.
Oh, you can't see the answer. Oh, you can see.
That time. Okay.
Oh, you can see?
Now, yes.
That's okay. Which is not one of the Newton's law of motion? Okay, so let me check the answer. Hope someone will put the answer. Don't answer. So D. Okay, good. Many D's. So is it D? Is it D's answer? Can we go for D? Okay, D. A body continues in state of rest or uniform motion in a straight line unless acted upon by some external force. This is not a Newton's law. Newton's law, which one? The D is the Newton's first law. An object will remain in rest or move with constant velocity unless acted upon by a external force. Yes, D is Newton's first law, inertia. Okay, so D cannot be the answer. It's Newton's third law, Newton's first law. Sorry. Okay. Any other answer? So D can't be the answer. It's Newton's first law. The others, anyone? It's all D, or some wrote B. So D is first law. C is which law? If body A exert a force on body B, then body B exert equal and opposite directed force on body A. This is Newton's third law, right? So C is Newton's third law. No doubt about that. So C is out. B. The rate of changes of momentum of body is directly proportional to the external force acting on the body and takes place in the direction of the force. This is Newton's second law. Force is directly proportional to the rate of changes of momentum. Okay, class, I need to correct a statement here. It's good to say that instead you say force is directly proportional to rate of changes of momentum. You better say the net force. The net force is directly proportional to the rate of changes of momentum. Okay, so far net force they ignore. Normally you say force, they give mark, but it should be net force. Net force is directly proportional to the rate of changes. So B, C, D is Newton's law. Okay, B is Newton's second law, C is Newton's third law, D is Newton's first law. A is what? Anyone? A is what? A is principle of conservation of momentum. A is principle of conservation of momentum. The total momentum before collision is equals to total momentum after collision for an isolated system. Okay, for an isolated system. So A should be the answer. Which is not one Newton's law. Definitely A is principle of conservation of momentum. PCD is Newton's law. Any questions from here? Everyone okay? Can understand? So those who got A, good. Okay, D is Newton's third law, Newton's first law in Asia. Okay, so let's move on. Okay, number 5, number 9. We did done this question. Okay, anyway, give a try. Number 9. What's the answer? Which you looks like a very correct way of explaining momentum. So put in your chat. Let me see. Okay, so let me check. Answer. Anyone? So all D. All going for D. Okay, yes, good. So D is the best, is the correct answer. The total momentum of system interacting body remains constant. The total momentum of the interacting body remains constant, providing no external force. Or you can say a closed system, or you can say it's an isolated system. Okay, so D is the best answer. A is what? A is Newton's second law. A is Newton's second law. B is not related actually. C, the momentum of the body is product of mass and velocity. Of course, it's a fact, it's correct, but never explains any momentum, never explains principle of conservation. Okay, so D is answer. Good. Okay, number 10. June 6, number 10. Cyclist is riding a steady speed on a level road. According to Newton's third law of motion, what is the equal and opposite to the backward push of the back wheel on the road? The back wheel pushes the road backward. That's the action. What's the reaction? B pushes A. Reaction must be A pushes the B back in opposite direction, right? So the answer should be what? So of course should be. Okay, what's the answer? Anyone? Well, okay, all got B. Yeah, good. Okay, so good, all got B. The forward push of road on the back wheel is a reaction. Okay, now let me ask you one question about action-reaction pair. Earth pulls you. Action. What's the reaction?
You pull.
Earth pulls you. Action. What is the reaction? Anyone give a try?
You pull.
You pull.
You pull the earth. You pull the earth. That's the reaction. Earth pulls you. Action. The reaction is you pull the earth. Okay.
You pull.
Okay. So this sounds funny, but it's reality. Earth. You are standing here. Okay. Let's say you are an object was dropping down. Let's say. So of course, Earth is definitely pulling you. Which we said is mg. Okay. This is your action by the Earth. Okay. The reaction is you pull the Earth up. Do you think the Earth does not experience force caused by you? The Earth experiences the same amount of mg, the weight force, upwards. Okay. So let's say you are 80 kilogram. Let's say your weight is 800 Newton. Okay. It's 800 Newton. That means when you fall down, the force exerting on you, action is 800 Newton. The Earth pulls you down 800 Newton. But you never realize that you pull the Earth up with same 800 Newton. That's the reaction. Okay. But we can, as I told you, why we never see Earth moving towards you? Because 800 is equals to ma for the Earth, the acceleration of the Earth. This is the mass of the Earth. But the mass of the Earth is so huge, so very huge. So the acceleration is going to be acceleration is close to 0. I've never seen is moving towards you. But we are going down with the acceleration of 9.81 because we are light. Okay. So Earth pulls you. Action. The reaction is you pull the Earth. What is the 3 condition for action and reaction pair? Anyone? I told you. For 2 force said to be action reaction pair, what 3 characters should have? It must be same magnitude. It must be oppositely directed. Third, it must act on the same body or different body.
Different.
Must act on the different body. Must act on a different body. Okay, good. So yeah, the answer is B. Okay, next 11. Okay, so in perfectly elastic collision between 2 atoms, it is always true to see that. What is the answer? The initial speed of one atom will be the same as the final speed of the other atom. The relative speed of between the 2 atoms equal to the relative speed of separation. The total momentum must be conserved, but a small amount of total kinetic energy may be lost in the collision. Whatever the initial state of motion, either atom can be stationary after the collision. Okay, let me check. Anyone got the answer? So all saying B. Yeah, good. B is the answer. No doubt about that. Relative speed of approach equals to relative speed of separation. U1 minus U2 equals to V2 minus V1. Only correct if it's elastic collision. Okay. A. When A happens, the initial speed of one atom will be the same as the final speed of the other atom. A is not wrong, A is it's a type of elastic collision. But when it happens, when that happens, A. Okay, this is a special case. Let's say you have 2 body both have to be the same mass. The second body have to be in rest. Okay, if the first body, let's say, incoming with initial velocity of u. Okay, if it's an elastic collision, if this is an elastic collision, what happened? The first body will immediately come to rest, and the second body will move with the same velocity as the first body. This is a special case. There is a half page of derivation to prove this. In A level, you have to accept this. This is a special case. So like a snooker ball line. So what is the condition for the first body come to rest and second body take up the same velocity as the first body? Two conditions. Of course, first it may have to be elastic collision. Second condition is the mass of the both body must be same. They have to be same. The M1, M2 have to be the same. If M1 and M2 not same, although it's elastic, the second body won't go forward with u. They're going to be less than u. Okay. So understand? So answer A is not wrong. Okay. Answer A is correct. It's about elastic collision, but not really explains the entire spectrum. This is A only if the mass is same. Okay. B, it covers the entire spectrum. C, what's the mistake? The total momentum must be conserved, but a small amount of total kinetic energy may be lost in the collision. How do you correct the statement? No loss in the kinetic energy. So elastic kinetic energy must be conserved. So that's a mistake there. Small amount of kinetic energy is lost. D, whatever the initial state of motion, neither atom can be stationary after the collision. D is wrong. Whatever the initial state of motion, neither atom can be stationary after the collision. Can be some stationary, some not stationary. So best answer is D. B. Sorry. Yes, B is answer. Okay. Okay. 12. 1 minute for you. Give me the answer. Okay, put it on the chat, your answer. Okay, class, because every time I have to scroll back to the team page. Can you put the answer on the WhatsApp? Easier for me to see from the phone. Easier. So what's the answer for the 12? Can put it in the WhatsApp. Two railway trucks of masses M and 3M move towards each other. Okay, so I'm receiving the answer. So A. So if you say A, the others also can refer from WhatsApp. Is it A? The others give a try. Is it going to be A? So you draw the movement of the object. Okay, draw the movement of the object. So I think I always like to draw the two body. So one is M, another one is 3M. So what is that? 2V and V, oppositely direction, towards each other with opposite direction. One is 2V with 2V and V respectively. M is 2V. Also, this is moving this way. So this is 2V, this is V. After that, they stick together and move together. We don't know where it moves. Just benefit of doubt. You put it to the right always. You're looking for this velocity, x. So momentum must be conserved. So what is the total momentum before? 2 mv positive, because of course to the right, positive to the right. So minus 3 mv have to be minus because to the left. So the total momentum before collision is actually negative mv. So what is the total momentum after? Must be the same. So it should be 2 mx because mass is combined we are looking for the x. Okay, so x will be what? X will be negative v over 2. It's negative v over 2. That means negative tells that our direction to the right is wrong. It's actually moving to the left with negative with v over 2. Moving v over 2. So is it B? A or B? Is anyone, any mistake I done? So I found it's B. Okay, so the others got B's answer. Should be B, right?
So the mass.
Oh, the mass, I made a mistake. One is M. Oh, sorry, yeah, correct. Then correct. So quarter, sorry. It's quarter. Good. So the answer is A. B over 4. Good. So answer is A. So my advice, please draw the diagram and then check whatever direction you stayed here. If the direction final movement, they never mention any direction, you just benefit of doubt, just put it to the right first. If it's moving to the left in reality, then your answer going to be negative. Okay. Okay, so A, B over 4. Okay, next. Okay, this one. This is November 6th, question 11. Interesting too. Okay, come on, give a try. If you don't like to send in the group, you can send privately to me the answer to the WhatsApp. I just want to see how many of you can get the correct one. The diagram shows two identical spheres, X and Y. Identical. Oh, same mass lah. So this is a special case. Initial X move with the speed of V directly towards Y. Y is stationary. The sphere collide elastically. What happens? So I'm receiving the answer D. So is it D? Yes, correct. This is the special case. Should be D lah. Should be D. What is the condition? The first one will incoming will stop, and the other one take the same velocity as the first one. It must be elastic collision. The mass for both of them must be same. If mass is different, D cannot be the answer. Okay, remember. If they are same mass, then yes, the first come to stop, the other one will move forward with the same velocity as the earlier one. Okay, so D is the answer. It's a special case. Proven. Okay. 12. Next question. Let me answer. What is the horizontal velocity of the cannonball? Give me answer. Okay, so someone said B, 500 meter per second. So all of you got 500. This 1000 kg. This is the explosion. This explosion, right? So B. Okay, so the cannon. Okay, the cannon and cannonball. The cannon is M1 and okay, it's M2. So all of them in rest. So the unique about explosion is total momentum before the initial momentum. The total momentum before is always 0. So after, of course, the cannon is moving backward and the ball moving forward. So this is your V1 and this is your V2. Okay, so it will be M1, V1, but V1 itself is negative. V1 itself is negative because moving to the left. So plus M2, V2. Okay, so finally, of course, M1, V1 equals to M2, V2. Okay, the direction has been considered. So you're looking for which velocity? What is the horizontal velocity of the cannonball? So looking for V1. We're looking for V1. So V1 is what? So M2 over M1 times V2. So M2 is the 10. M2 is which? Oh, sorry, the cannon recoil is 5. What is the original velocity of the cannonball? Oh, sorry, we are looking for M2. We are looking for V2. I made a mistake. So it's V2. So V2 should be what? Should be M1 over M2 times V1. Okay, makes sense. So it's 1000 divided by 10. So you got 100 times 5. So 500. Okay. So 500 meters per second. So B is the answer. Okay, B is the answer. Okay, good. Okay, one structured question. Okay, this question is this question is very interesting because this is something related to radioactivity, which you never learn. You're going to learn that in the last topic of your AS. Okay, what I want you to do is the last part. You see, read the question. A francium of 208, emitted alpha particle, and with the kinetic energy of that joule from a nucleus, astatine, as illustrated. Astatine going up, alpha going down. Okay, francium originally is francium, will break into alpha and astatine. Okay, alpha move with the 10% of speed of light, so astatine have to recoil backward. Okay, state the nature of alpha particle. For time being, you should not know, but you already learned before, right? What is the nature of alpha particle? It's a helium nucleus. Okay, it's a high-speed helium nucleus. That's it. Can't say helium atom. You will be learning that later. For time being, I don't expect you to answer this. Okay. Second, B. Show that the initial speed of alpha particle after the decay of francium nucleus is approximately 1.8 times 10 power meter per second. Okay, how do you do part B? That's the question now. How do you do part B? Okay. Part B, they're asking, what is the speed of, show that the initial speed of alpha particle after the decay francium nucleus is, show that alpha speed is 1.8 times 10 to the power of 7. Astatine kinetic energy was given. Okay. So anyone can get me the answer. Final answer is 1.8 times 10 to the power of 7. How do you work out this answer? Okay, how do you work out this answer? So this is a collision. So this is a type of explosion. Okay, it's a explosion. Originally was francium. Okay, originally this is francium with a mass of how much? What is the mass of francium? Is 208. The nuclear number is 208. Nuclear number 208 means 208 U. U is a certain constant line. If you want to write it in kilogram. 208 U. U is called atomic mass unit. Okay, it's a constant. You haven't learned that. You will learn later. Okay, now this francium is break into two. One alpha, and the remaining is astatine. Okay, astatine. Okay, they're asking what is the alpha speed? What is the speed of alpha? Okay. Do you know mass of alpha? Mass of alpha is helium. Mass of alpha is a helium nucleus. Helium, I believe you can remember the helium. What is the nuclear number of helium?
Wait.
Helium?
4.
What is the proton number?
2.
2. Good. Yeah. So what is the mass of alpha? Is 4U. It's 4. So 4U. We put it 4U. You need to times with U, some constant to find the mass in terms of kilogram. Okay. Now, do you know the astatine speed? Do you know the astatine mass? What is the astatine mass? Anyone? Originally is 208U. It breaks into two parts. 4U become alpha. So what is the balance?
16.
Balance number 208 one. 208U. For you become
208
alpha.
to
So the
204.
balance is 204. And 204U is the mass of the astatine. The mass of the astatine is 240U. Okay. So now the question is find this alpha velocity. So what principle do you use to find the alpha velocity? What principle do you use? Principle of conservation of momentum. Momentum is conserved. This is the explosion one. Momentum have to be conserved. Momentum of alpha must be same as momentum of astatine. The momentum of alpha have to be same as momentum of astatine. Okay, right? Because total momentum 0. So momentum alpha plus momentum of astatine. Okay. Alpha momentum is negative because it's moving to the left. So you bring the other side. This is what will achieve. They are same. Momentum alpha is same as momentum astatine. So mass of alpha, speed of alpha we are looking for. Okay, mass, mass is 4 for you. Okay, P alpha we don't know. Mass of astatine we know is 200 for you. Okay, how do you find speed of astatine?
1/2 mv squared.
Yes, good. Use half mv squared. Okay, so mass, the velocity of astatine we calculate by using half mv squared. Half mv squared. Half. Sorry, I write here. Okay, so let me expand. So half what? Half mv squared equals to the kinetic energy of the astatine. Kinetic energy of astatine. Here, half mass you put what? 200 for U. U as its own value. In your nucleus, you will start to study about it. It's 1.6 times 10 to the power of negative 27 kg. It's a constant. You don't need to remember given in your exam. It's U. So you can find the final velocity of the astatine. Okay, kinetic energy no already. So find the V. So after you got your V, you can put it here in terms of momentum. You can find the speed of alpha. Okay, so any question here, you don't need to do, but understand the flow. What you should do. We use conservation of momentum, and later we use kinetic energy to find the velocity of the alpha, velocity of the astatine. So we can find alpha based on conservation of momentum. Any questions from here? Okay, because the actual question I want to discuss is the next one. Okay. Okay. So if you follow that idea I told you, you will get 1.8 times 10 to the power 7. Okay. So next, C1, state the principle of conservation of momentum. What is it? The same principle for an isolated system, total momentum of the system is conserved. Okay. Okay. This part I want to skip. I just want to ask you the last one. The question why I'm choosing this structured question, just to ask the question D. Question D. You need to think. Okay. 1 minute for you. Close examination of the decay of a francium nucleus indicate that the astatine nucleus and alpha particle are not ejected exactly in opposite direction. They saw in the cloud chamber, they found that the alpha and astatine not moving opposite direction. Suggest an explanation for this observation. If a scientist sees that, that alpha and francium, alpha and the astatine, which is the daughter particle, the product, never move in opposite direction. They move diagonally like this. What is the scientist will conclude? What is the scientist will conclude?
The total momentum.
They break. One is moving here, alpha. Another one, the astatine moving like this. the angle is not 180, maybe 120, maybe. The angle is not opposite. So what the scientists make a conclusion about this collision?
It's not an equal opposite reaction.
Okay. Okay, is it momentum conserved in nuclear reaction?
Mm,
Is it momentum conserved in nuclear reaction?
technically, no.
Your previous knowledge. Is it momentum conserved in nuclear reaction?
Right.
Yes, momentum is conserved in any type of collision. Okay. So in nuclear reaction, momentum is conserved. What is the total momentum before explode? 0, right?
Okay.
Interest one. So after explode, the total momentum also must be 0. But to be 0, they have to travel in opposite direction. But they are moving a little 180, 120. That means to make it momentum conserved, we know momentum is definitely conserved. To make sure that momentum is conserved, that means there is another third particle is moving this way. There is an unknown. There is an unknown third particle. It should move this way.
Or is this because of the thing that we should learn in the final chapter?
Under conservation of momentum. Because momentum is conserved for a nuclear reaction. If it's only breaking into two parts, they have to be in opposite direction. But it moving in 120 or something like that, smaller than 180, that means the scientists will conclude that there should have some third particle, unknown particle, which cannot be detected in the cloud chamber. That means it should not have charge. It doesn't have charge, but it has some mass which carries some momentum this way. So this is the prediction. Okay. So what's the answer you supposed to write? Suggest an expression for this observation. So you have to say that the nuclear reaction momentum is conserved. Okay. So based on this principle, they should have third particle exist in this explosion. Okay, which is moving to the what? In the southeast direction. That's the answer. So any idea? Any clarification required? Do you understand what I'm trying to say? Okay.
So like we should say that there is an unknown.
There is an unknown particle in this explosion which carries some momentum to the southeast direction. Okay, then only momentum will be conserved. If a body break into three components, means one will move here, another one is move here, another one is move here, depend to the mass. But they won't make 180. There'll be a short angle. So in this explosion, they found two of them moving like this, not 180. That means they should have a third particle moving this way to balance the to obey the conservation of momentum. Okay. So principle of conservation of momentum is definitely obeyed nuclear reaction. But what they conclude based on that, they found that the third particle. Okay. So now, yeah. So this is how you have to answer this part. Okay, conservation of momentum. Any questions so far? Okay. Okay. So class, another last question before we stop. Okay, very good question. November 7, question 7. What's the answer? Think carefully. Give me answer in the WhatsApp. The symbol G represents the acceleration of free fall. Which of these statement is correct? Anyone? This is the last question for today. So I'm receiving answer. Okay, good. Okay, so many of you. Okay, C. Yes, good. The answer should be C. Okay, it should be C. Why can't be A? G is gravity. Gravity is the name of the effect, actually. The gravity is only the name of the effect. The gravitational effect is the name of the effect. So G is not gravity. G is actually weight divided by mass is gravity. The G stands for acceleration of free fall. Okay, so A is gravity, not accepted in real life because gravity is the name of the effect. Okay, G is actually acceleration of free fall. So F equals to ma, weight divided by mass gives you the G. Okay, so C is the proper answer. To B happen. To B happen. Is it gravity affected by air resistance?
Oh, that's the object.
So is it gravity affected by air resistance?
No.
No.
No, gravity not affected by air resistance. Unaffected by air resistance. G is weight of an object, of course not. Okay, so answer is C. Okay, class. So we're done with this topic. You have plenty of questions in this file. I want you to give a try. So on Monday, maybe for the first half an hour, I'll ask questions from here. I want you to give a try most of the questions. More you do, more prepared for this topic. Okay. So yeah. So Monday we will start a new topic, topic 5, forces. Before that, half an hour we'll discuss any questions if you have in this dynamic. Okay. Yeah. Any questions so far? No questions. Okay. About giving answers, I want everyone to give a try. Okay. So some of you don't want to try. I just want you to give a try. Okay. Try to involve in the discussion. Okay. It's better for you. Okay. Okay. So see you then next Monday.
Teacher,
Yeah.
I have a question.
Yeah. Which question?
November 9, 11,
November 9/11.
15,
Oh, November 9/11. Page what?
page 30. This one.
Oh, 30.
Number 15.
Oh, 15. Okay, class. Okay, let's see. Last question. Okay, maybe you also might face the same problem. Okay, give 1 minute for you. Two trolleys are placed together in the horizontal runway with compressed spring between them. When they are released, the 2 kilogram trolley moves to the left and 2 meters per second. How much energy was stored in the spring? The 2 kilogram trolley moves to the left at 2 minutes. Oh, okay. This one, you need to use what? Conservation of energy and also momentum. You have to use both. You see, they're asking what is the energy stored in the spring. Okay. Tell me for this case, what energy changed to what energy? The potential energy of the spring, the elastic potential energy of the spring converted to kinetic energy of the both trolley, right?
Yes.
Both trolley. Okay, so that's how you work out lah. So you work out the half. So the potential energy of the spring, okay, of the spring should be equals to the EK of the both trolley, EK of 2 kg and of course EK of the first kg lah. Okay, so that's the first point you have to know. Second, how to find kinetic energy of 2 kg? Half mb squared plus half mb squared. Okay, so this is 1, this is 2. Okay, so V1, do you know? V1 is the 2 kg, right? V1 is how much? 2 meters per second. Okay, so half m is 2, v is 2 meters per second, so 2 squared. Okay, plus half 1. Okay, so we don't know the speed of the 1 kg. So how do you find speed of the 1 kg? We need to know the speed of the 1 kg. Then we get the answer already. So how do you get speed of the 1 kg? What speed the one moving to the right? So we use conservation of momentum. So both body at the beginning in rest. Okay, it's explosion. Okay, after explode, the 2 kg move to the left and the 1 kg move to the right. Okay, so can you find the velocity of the second one? Because if you know the velocity, we can put it here, you can get the answer. Okay, so 0 what? 2 times 2, 2 times 2, negative 2, because moving to the left, plus 1 times V2. So find V2. What is V2? V2 is 4. This is 4. So this is 4. So it's going to be half times 2 times 2 squared plus half times 1 times 4 squared. So this is your final answer. What's the answer you got? 8, 4, 4. So 4 plus what? 8. So 12 is it? So you get 12 joule. You get 12 joule. You get D.
Yes.
Answer is it D? D,
Yes. Yes.
Okay then. So do you understand the book?
Okay. Yes.
Can okay then.
Okay.
Okay, class. Okay, keep it up. See you on Monday. The first half an hour we discuss any question arise in dynamic. Then we continue with the fifth topic. Okay. Okay, we stop here.